In this video, we are looking at the following: how to prepare for a ballast tank inspection and where to find potential problem areas. In part 2 of this series, you will find information on the actual inspection and reporting. Let's first have a look at why we need to have regular tank inspections. We want to be sure that the ship is still safe, and we want to have a realistic overview of what steelworks need to be done during the next repair period. Replacing 10 tons versus 100 tons of steel make a big difference in price. How to prepare for an inspection. So how should you prepare for a ballast tank inspection? Correct. You will need to get some steel drawings out: the general arrangement, the midship section, and the shell expansion. On the general arrangement, you can see the tank borders. Let's assume we're interested in ballast tank number 4, port and starboard side. You can see that it ranges from frames 54 to 62. Note these borders down in your notebook for later. You can also see that the tank is L-shaped, meaning the sides and the double bottom are connected. On the midship section, you can see the tank layout. You will see we have, in this case, 3 compartments in the side, 1 in the bilge area, and 3 in the double bottom area. In the side part, we have 3 stringer decks, and in the bottom part, we have 3 bottom girders. You can also see that we have various sets of longitudinals. In the bottom part, the inner bottom, the lower hopper part, the side shell, on the longitudinal bulkhead, the upper hopper part, and on the main deck. All this information is important to find your way later on and to correctly name corroded or damaged parts inside the tank. On the shell expansion, you will find additional information. In this case, you can see that frame 58 is different to the other frames. This information will help you later on in the tank to know where you are. You can also see information on welding seams. For example, if you want to verify an indent from the outside, counting welding seams will help you to find the exact position. Many other drawings can prove to be useful as well. Following the same principles, you could have a look at the inner bottom, main deck, or bulkhead drawings. Remember to take your time to prepare for the inspection. This helps you to find your way later on and to correctly name the damaged parts and locations. Now let's have a look at the areas of concern. Do you think you can somehow foresee where you might find problems? Yes, you can. So let's have a look at potential issues you might encounter and what causes them. For sure you will remember that there's a thing called bending moment. And you will also know that the biggest impact of the bending moment is in the middle of the ship. That means that structural damages originating from the bending moment will be found in the midship structure, close to the main deck or bottom on transverse bulkheads and web frames. Check bracket connections for cracks. If you find these cracks in the midship area, check the frames forward and aft of the cracks as well. You might find more. Next to the bending moment, you have shear forces. Shear forces are unaligned forces pushing one part of a body in one specific direction and another part of the body in the opposite direction. For a ship, that means the weight distribution of the vessel minus the buoyancy curve gives us the load curve. If we now integrate the load curve, we get the shear force. Your load computer will have done this job for you. You can now determine where the shear forces are highest for your ship. Typically, that is on the engine room forward bulkhead and near bulkheads between empty and laden cargo holds. Typical damages originating from shear forces are 45-degree cracks in transverse webs or brackets. If you find one, you will most likely find more. So remember, the bending moment can give us trouble midships, close to the main deck and bottom area, and shear forces close to the engine room forward bulkhead and near bulkheads between empty and laden cargo holds. We have now finished part 1 of this video. If you want to know more about tank inspections, have a look at part 2 of this video. In this video, we are looking at tank inspections and reporting. In part 1 of this series, we have already talked about preparation and areas of concern. So what to do once you're inside the tank? In this video, we will only discuss the technical details. Don't forget the safety aspect, an enclosed space entry permit, a safe atmosphere, a colleague standby at the manhole, and of course correct PPE. In order to give an accurate description of damages that you might find, you need to remember where you are at all times. If you have noted down the bulkhead frames of the tank, you have a good reference point to count frames. You might want to start in the double bottom aft between bottom girders 1 and 2, work your way to the forward bulkhead and then move back between girders 2 and 3, or any other system will do. Count the frames so that you know where you are. You could bring a permanent marker or chalk and write the frame numbers on the respective frames. In part 1 of this video, we have talked about areas of concern, structural problems caused by the bending moment or shear forces. When you enter the tank, you should have these factors in mind and have a closer look at these areas. But there are also other things we're interested in. So-called hard-soft transitions might give us issues. Try to imagine both of these ships hugging and sagging. Which ship do you think might have a problem? Correct. The one at the top might have an issue here, while the one at the bottom is much better designed. The same is true for other hard-soft transitions. Pay attention to brackets and stiffeners and check for cracks. The connection you see here on the left is very abrupt and you're likely to find cracks. The bracket toe on the right is much better designed and less likely to have any problems. Around the waterline area, there is a possibility you find contact damage, indents resulting from fenders, tugs, floating objects, or simply big waves. If the vessel is alongside, you might already want to have a look from the outside to see if you can spot indents that deserve a closer look from the inside. If you spot a dent from the outside, find a reference point on deck to verify the frame number against the general arrangement. A deck house or tank borders painted on the hull can serve as a reference. Count welding seams for the location over the height. The shell expansion drawing will help you for more details. In the forepeak, you might find damages in the bottom area resulting from slamming, sometimes even extending to the first tank behind the collision bulkhead. Also in the forepeak, you might find contact damage from the anchors. Be aware to pay special attention to that sideshell area. Another area to pay attention to is bulkheads that separate a ballast tank from a heated fuel or cargo tank. Heat accelerates corrosion, and these bulkheads are the first to suffer. Edges and piping usually start to show signs of corrosion first. This is because of a lot of attention is needed during the new building coating process. Stripe coats have to be applied manually, and sloppy workmanship will soon show results. The plating under the bell mouth can be subject to cavitation damage. You should always feel the area underneath with your fingers. We would also like to know how the coating looks like. Try to be as accurate as you can in your description. You will have to break down the tank in areas to give a realistic overview. Most likely the plating will have a better coating condition than secondary structure. We are also interested in the condition of the anodes. Note down to what percentage they are wasted and if they need to be replaced during the next docking, or maybe already earlier. Or are they not used at all and still look brand new while you see corrosion in the tank? then something might be wrong. Give us an estimate of how many cubic meters of mud are in the tank. Mud is very expensive to remove if done during a yard stay. If there's a lot, we might want to try flushing before our next docking. You can calculate later on. 10 centimeters of mud over a bottom area of 15 times 30 meter equals 45 cubic meters of mud. In Curaçao, to remove 1 cubic meter of mud costs $485. You see why that information is important to us. Remember, you're looking for hard-soft connections, contact damage, hot-cold transitions, edges, piping and fittings, the plating underneath the bell mouth, the coating condition, anodes and mud. Let's now have a look at the reporting. Use the form that your management company provides for tank inspections. This will make sure that you don't forget anything. When taking pictures, it is best to take an overview picture first and then take a close-up. The picture on the right without any explanation does not say much. Something somewhere is heavily corroded. For damages, we want to know where the damage is and to what extent. Writing the frame or location number on the damaged area will help you later to identify what you are looking at. A permanent marker or chalk comes in handy. Be as accurate as you can when reporting damages. This takes time, we know. A decent tank inspection can take a few hours, especially if there's a lot to report. A mere statement that there's some corrosion in the tank does not mean anything. We want to know the scope for the next repair period. Provide approximate dimensions. You will get more information from the midship section and shell expansion drawing. For example, ballast tank number 4 port side, frame 54 to 55 in way of side shell longitudinal 33. There's a soft dent of 200 by 300 millimeters with a plate thickness of 12 millimeter. The longitudinal is affected over a length of 300 millimeters. Or ballast tank number 3 starboard, frame 62 to 63, stringer deck number 2, there is visible corrosion around the manhole and an estimated insert of 400 by 800 by 8 millimeters is needed. Or forepeak, stringer deck number 3, frames 102 to 110, there are 8 brackets in the centerline girder found with visible thickness diminution. 8 pieces of 150 by 150 by 8 millimeter. There are tables that can help you judge the coating condition. They look like that. Let's have a look at an example. This picture would say, shell and bulkhead coating fully intact, less than 1% coating breakdown on edges and piping. This picture could say, shell and bulkhead about 5% coating breakdown, mainly around the welding seam to stringer deck number 3. Stringer number 3 shows about 10% coating breakdown in the aft part. Pictures say more than words, so make sure you have a lot of them. It is not so very important that you get the percentages right. We just want to have a quick indication of how good or bad the coating is. If it is now 20 or 30% coating breakdown does not really matter. However, we prefer percentages over the classical good, fair, poor judgment, as this can be very subjective. Also let us know if a certain area is inaccessible. Nobody expects you to climb around, but let us know if you have suspicions. For instance, aft bulkhead adjacent to heated fuel tank looks heavily corroded, however, only the lower 2 meters could be inspected without staging. Remember when it comes to reporting, use the forms provided and take meaningful pictures. Be as accurate as you can to describe damages. Give information on coating, anodes and mud as well. And let us know if a certain area was not accessible. Many thanks for your attention. We hope that you have enjoyed this video. See you next time.